exciting talks before, very entertaining, and probably this one will be not so entertaining, but hopefully you'll still find it interesting. So I'm a software engineer at Google. I've been at Google for about 6 years, and for the last 2 years, I've been working on this cool project called Service Weaver, together with other very smart folks in the team. So yeah, Service Weaver, it's a framework for writing distributed applications. It's an open source framework, so we welcome all of you guys to use it, and you can find it here. So let's start the talk. So microservices are increasingly popular. In a microservice-based application, you split your application logic into independable deployable binaries that communicate with each other over network. And as you see in this Google Trend chart, the popularity of the microservices has been increasing over the years. Also, we as a community, we've been building all these tools and technologies which basically help to further grow the microservices ecosystem. For example, containers and Kubernetes for flexible and easy deployments, service meshes like Istio for interconnecting microservices, CI/CD pipelines like Argo, Open Telemetry, Prometheus, other things for observability, and so on. At the same time, we as a community have very opinionated and contradictory views on whether microservices are good or bad. If you go on the internet, you'll find countless videos, blog posts, articles about why you should use a microservice-based architecture or monoliths or whatever. We took a random Reddit post and look at some of the comments, and I'll just briefly mention here. So for example, one person says microservice architecture is the worst of a distributed monolith. While another person says microservices actually are not bad, it's just we don't do it the right way. And one reason is because we don't know how exactly to split at the right boundaries. Another person loves microservices because they just hate monoliths. While another person actually doesn't even know whether their architecture is a monolithic or a microservice-based architecture. And this kind of confusion and controversial opinions are also exacerbated by the trends in the industry. For example, large companies like Uber, Etsy, eBay, and AWS, they like microservices, and since many years ago, they keep migrating their monoliths to microservice-based architectures. At the same time, a few months ago, AWS wrote an article describing how they migrated back from a microservice-based architecture to a monolith, their Prime Video stack, in order to reduce costs by 90%. So as you can see, microservices are quite popular. However, this continuous discussions whether they are good or bad and when you should use it or not is still an open question. And we, based on all this opinion and also based on our experience of writing applications, we identified 3 main challenges why people can't get the correct answer to this kind of question. And here are what we think is the problem. First of all, there is no guidance or standard best practices on how to write distributed applications. Should you write your application as a monolith and keep it for as long as needed, and then at some point, you may split it into microservices? Or maybe you should start, split your application into microservices since the beginning, since you design your application, and split as much as you can, because later on, once you deploy it, it will be very hard to change. Second, we don't live in a clear black and white world where microservices or monoliths are good or bad. Unfortunately, it's all about the trade-off space. It's a vast trade-off space where we talk about trade-offs related to ease of development, ease of deployment, testing, observability, and so on. So me as a developer, if I want to deploy to write a new application, I have to identify where my application requirements are in this trade-off space. And this is an extremely challenging task to do when I'm designing my application because I don't have the knowledge and experience to know what is the best strategy for me at that point. And the third challenge is, frankly speaking, the whole ecosystem is very complicated. The cloud APIs are complex. We have lots of technologies and tools there, and once we feel comfortable using one of these tools, suddenly there is a new one or a new technology coming which is being released and arguing is better. Also, oftentimes we design applications based on bias and not on technical reasons. For example, we see like Google, AWS, Uber, whatever, they like microservices, and they split their monoliths into microservices. We believe microservices are great, and we should split as well, even if maybe our use cases or requirements are different. But this is what people do, so we don't. At the same time, maybe we've used some frameworks in the past which we have some bad experience, and we believe that they have fundamental limitations. And that prevents us to adopt any new framework, even if the frameworks are willing to help us with our applications. Corba is such an example, and we get so much hate because of this, actually. So given these three challenges, we came up with three core ideas as a solution to these challenges. First, we believe that the developer should write the application as a modular binary and deploy it as a set of microservices. We believe that having the decoupling of logical boundaries from the physical boundaries, it allows the developer to change the physical topology of their application later. Second, we believe the developer should focus on writing code and delay the monolith versus microservices decisions for later in order to minimize the need for trade-offs. So we believe you should start your application, just focus on the code, and once you get more experience and knowledge about how your application behaves, then you can think what is the best strategy for you and what you want to do, whether a monolithic or a microservice-based application to use. And last but not least important, we believe that the developer should focus on the application business logic, and because that's his or her strength, and they know better what to do in that space, and offload all these complexities of cloud interactions to the runtime. And we believe that the runtime can make opinionated decisions of which underlying technologies to use for different use cases better than the user of the application. So we took these three core ideas and we implemented them in a framework called Service Weaver, which is a framework for writing microservice applications. With Service Weaver, our goal is basically to make it easier to develop, easier to deploy, and maintain high-performance applications with reduced cloud costs, and also allow you to deploy the same application across multiple clouds. In the rest of the talk, I'll dive into the details of how we do this, and I will talk about how we develop applications. With Service Weaver, you deploy your application as a modular binary in a single binary, and you write code using native language program features, and you don't have any code versioning concerns. Once you have this binary, the Service Weaver runtime will deploy it for you as a set of connected microservices, and it allows you to deploy the same application binary without any changes to the local machine, to a Kubernetes environment, to a pool of machines, and so on. The Service Weaver runtime is high performant, which allows your application latency to be reduced drastically, and the cloud cost as well, comparing with status quo. And finally, provide tools, for metrics, logging traces, and so on, to debug and to understand the performance of your application. So let's go a little bit into more details how actually we achieve these kind of things. So in terms of development, a Service Weaver application consists of a set of components that call each other, where a component is similar to an actor unit for those familiar with the actor models. Under the hood, Service Weaver has a code generator which weavifies the application. So you basically generate all the code which will run distributed, like we generate encoding, stubs, registration, metrics, and everything. Then the developer writes this modular binary where they define their services around Go interfaces, and then the Service Weaver runtime will deploy this on the local machine in a single process, in multiple processes, or in a distributed environment. Multiple machines, multiple pods, replicated, traffic load balanced, and so on. All right, now let's see a little bit what is the developer experience of writing a Service Weaver application. As I mentioned before, one of the key abstractions is the component. which in Go you represented as a Go interface. Here in this example, I'm showing you how you implement like a cache component with a put method. And of course, you can have other methods as well. So you literally write just a Go interface. Now, to implement the component, you have to literally write a Go struct. The only difference is you have to add the weaver.implements embedding. And this is to let the service viewer runtime understand that this is a service viewer component and should be treated accordingly. Now, in a service viewer application, there will always be like a main component from which you instantiate the program. And for that, you have to write like a main component. The only difference is the embedding has to specify the main component. And then you can get references to all the other components by using a weaver.ref embedding. To instantiate a service viewer application, you simply call weaver.run, where you specify which body you want to run in the Weaver application. In this case, we want to run the main component, which is called app. And finally, to interact with the component, in this case, we want to interact with the cache, let's say to insert a key value pair, we just simply do cache.put. As you can see here, this is mostly Go code. I mean, you don't have anything about Protos, about encoding, you don't have any like HTTP servers, any registration, any service discovery, nothing. It's mostly Go code, and it looks like it's kind of the code which can run on the local machine. Now, let's look a little bit like, OK, so you write an application this way. This application is compiled into a single binary. Let's see how it's actually being deployed by Service Viewer. So yeah, the Service Viewer takes your binary and releases a single binary. You can simply run a Go run on the local machine, and your binary will just run. Or you can write a config and do the same thing. If you want to run this in multiple processes, then you have to add, you basically just run Weaver multi-deploy. If you want to run in a distributed environment, then you have to add a per deployment like little config. For example, if you want to run, these are kind of deployers we have right now. If you want to run like on a pool of machines reachable by SSH, you just have to specify the locations of these machines, and then Weaver SSH deploy will run the same binary without any changes from the local run on this pool of machines. Same way, if you want to run your application in a Kubernetes managed cluster, you can use the Weaver Kube deployer, which will generate all the YAML files, all the services, all the deployments, integration, horizontal pod autoscaler, everything for you. And then you just do kubectl apply, and you can run it in GKE, KS, AKS, whatever you want. And finally, we have a Google Cloud GKE deployer, which is very powerful, actually. And in this deployer, you basically specify, for example, the regions where you want to deploy and like which public listener, like which URL you want your application to be available. And again, Weaver GKE deploy, same binary, you just deploy it in the cloud. And under the hood, this deployer will basically create clusters for you if you don't have. We'll do rollouts for you, to balance the traffic, and we'll start to do a lot of crazy stuff. One nice thing about this deployer is like it's easy to add new config knobs in case you want more control to customize the deployer further. At the same time, if you don't like any of these deployers, or maybe you want another deployer, for example, for WebAssembly or something, then the abstractions are designed in a way where it's kind of very intuitive and easy to reason about how to write a new deployer. And my colleague Michael actually wrote a nice blog post about how to write a new service viewer deployer. So that's another option for you. So under the hood, let's see how this thing is actually deployed. So as I mentioned before, you write your application as a modular binary where your services are split into components. The service viewer runtime will take your components and will place them in processes. By default, each component will be placed in a separate process. And I didn't mention, but in the config you have some collocation policy where you can also decide how you want to collocate them together in case you want to do that. Then the Weaver runtime adds these Weaver libraries to your application, which basically manages the interaction between the application binary and the runtime. And finally, we have the runtime, which we can have multiple implementations. Right now, we have an implementation for the local, for pool of machines, for GKE, for anything else. Yeah, let's quickly look at the performance. As I mentioned before, Service Viewer runtime is highly performant. So let's see what kind of features do we have so far. So for example, we do our own custom encoding, decoding. We don't rely on protobuf, we don't rely on JSON and anything. because we don't have any versioning concerns in the way we deploy the application. And this is like way much faster than any other encoding decoding mechanism out there. We have a custom transport built on top of TCP with custom load balancing, which is actually much more efficient than gRPC. We have we provide collocation. So basically, we provide you the flexibility to collocate some components in the same OS process. So let's say you run your application and you have two chatty components. You can decide as a developer to place them in the same collocation group, and then we'll make sure those will be always deployed together, and they will communicate over direct method calls, and there is no networking involved. Or if you have two components and you want to achieve different security isolation domains, then you can place them in separate groups. And finally, another one is routing. This one is especially useful if you want to we have like soft state in memory, let's say like a cache in your microservices, in your like services, and then the routing will help you basically to increase the key, like the affinity, and again, it'll improve the application performance. And here I'm showing you like some benchmarking. It's a very preliminary benchmark we did on one of the existing applications. So we took the online boutique, which is like, I don't know how many of you guys know about it, but it's like a application advertised by the GKE folks. It has 11 microservices, and they are written in different languages. So we ported that to Go, because that is a fair comparison, because we only support Go for now. And we ran this in GKE, in the Google Cloud, with a fixed workload, comparing the microservice version of the app and the Weaver version of the app, where all the components are in separate processes. And we look at several metrics. One of them, we look in the reduction in the Go code and the config code. So in terms of Go code, as you can see, we definitely have less code here. It's not as big as you can expect, but actually recently we ported another app called Bank of Anthos also, and the reduction is 50%. And this is mostly because we get rid of all this boilerplate code about serialization, about Protoss, about HTTP server registration and stuff like that. Config code we can't really compare because microservice-based applications, they have YAML config files, and for this application I think was the 1,500 of lines of YAML files, and you saw for the config code for us it's like 5 lines. So there is no way we can compare that. In terms of performance, here you can see how many CPUs for this particular workload the Weaver application run and the microservice version run, and also the 99% latency, and 50% latency is kind of the same. And yeah, I think the graph says everything. In terms of telemetry and testing, Service Weaver provides tooling to help the developer basically understand the behavior of their application and to debug the application. For example, every component in Service Weaver comes with a logger by default, which is basically a wrapper around slog. So it has the same semantics as slog. And also we have nice tooling and commands where you can do all kinds of manipulations on these logs if you want. We have metrics, so we created our own metrics, counter gauges and histograms, and also we generate metrics for you. For example, the generated code already provides you metric to understand like how much data you transfer between services, what is the latency of this request, and stuff like that. And also actually provide dashboards. You can see the call graph and like all the you can understand like where are the performance bottlenecks in your application. We integrate with Open Telemetry to provide you tracing. So you just need to enable to create an OTel handler in order to for us to track all the HTTP requests and component method calls for you. And finally, we also provide profiling. So with a simple command you get, you can capture the performance of your whole application. So because it's GopherCon, I'm going to go a little bit like how did we use Go for this project and what kind of exciting things we found for us. So one thing is for the implementation, we rely on generics and embeddings to create our Service Weaver abstractions, and this would not have been possible without these two primitives. We generate code. So this is just a snippet of some registration code. So this is something which we found very powerful and relying on the Go libraries to do that. And finally, when we create metrics, all our labeled metrics are generics, and they can take labels as a struct. which we found it very nice, to have labels as struct, where you can specify the type and the name. Because an alternative API would have been like just to specify a list of these things, and it would be very hard to identify the type, and you mess up, very easily. And we couldn't really find libraries in Go for metrics, which are much better. So yeah, that's kind of the talk. Let me quickly go over like a small showing a little bit of code here of how Service Weaver actually works. So here, we did this in a workshop last night. I mean, I think some of you already saw this. But basically, if you want to write a simple application where, given a query, you want to return the list of emojis which match the words in that query, how do you implement the Service Weaver way? So to do that, one option is you create like a searcher component, for example, with a search method where, given a query, it returns a list of emojis. And the emojis are like in a file here, we hardcode all the emojis and the keywords for each emoji. So to do that, we create this searcher component, which have a search method, which takes basically the query and returns a list of emojis. Note one thing I didn't say in the presentation is like in Service Weaver component, we always return an error. Every method returns an error because these methods can be executed local or remote. So we don't hide the network or anything. So the error are still surfaced to the developer at this point. Now to implement this searcher component, we simply create a Go struct where we add the weaver.implements embedding, and then we implement the search method, which is basically just Go code. We split into strings, we lowercase them, and then we look in that map, in the emojis map, to return the strings. So that's what the core functionality is. Now let's see how the main looks for this program. So as I said before, you need, in a Service Weaver application, you need a main component. So in this case, we have the main component, which is, this is the way you mark that is the main component. And of course, we need the reference to the searcher component because, the searcher component is the one doing the logic, returning the list of emojis. And then a listener because, you want your application to be reachable, from outside. Now, to start the Weaver application, basically, we do, just weaver.run. And in the run body, we basically just don't do much. We just, exported an endpoint like search, on which you're you can you can provide the queries you want to get the emojis. And inside this, basically, we invoke the searcher. Whenever you get a new query, we just invoke the search method on the searcher component, to get the list of emojis, and you return it. And of course, we also, expose an HTML page so where you can have a nice front end. But this is not a Service Weaver thing. So that's it. And let's see how this works, actually. So if I go here and I do just go run, this is basically we run this application in a single process. And I can see this because, for example, if we do this Weaver single status, here you can see that we have two components, emoji searcher in the main, and they have the same PID, and it's replicated one in the once. Now if you go and to, what was the listener port? 34399. If you go to localhost 399, I can just do a query, and it returns all the emojis for this. But if I say a black cat, I think it returns like this. Next thing what I can do is I can run the same application now, but in multiple processes. So to do that, I need a small config where I have to specify for the multi-deployer, for example, in this case, I want maybe a listener and to listen on this fixed port. The only thing I have to do now is I have to run the same, I just have to run the Weaver multi-deploy config command. Sorry, I missed something. Oh, yes. So this starts the multi-process deployment of the app. Here we see we have actually two replicas. So now each component is replicated twice and listening on 9,000. And if you go again, localhost 9,000, same thing. Pig, yeah, cat. And here if you do now Weaver multi status, now you see that we have two components, but each of them is replicated, and all the replicas have different PIDs. And finally, OK, you test it locally, run it locally, you change some lines of code, you run it again. Now, if you want to, let's say, run it in GKE, for example, the only thing you have to do is you have to have a small config like this. You can do this, and then you add it here. Sorry, I messed up a little bit. Yeah. For example, you can specify which regions you want to deploy and where your application want to be available. And the only thing you have to do now is same thing. Stop this and say just instead of multi, we say GKE. This will take a bit of time because it will. I think for this example, I didn't pre-start any class or anything. So it will build the image, it will create the clusters, we'll deploy the application to the pod, and so on. So this will start working for a while. But then if you go to this link already, we already have a version of this running. You'll see the same application running in Google Cloud, actually. So yeah, so this is what I want to show here. The project is available at serviceviewer.dev. We would love you to try it out, to contribute and give us feedback. And more importantly, we want to work together with us to help you integrate with ServiceViewer and also to identify what are the right directions we should follow for the project. With this, I conclude my talk, and thank you.